So a rectangular plot of farmland will be bounded on one side by a river. So first we'll draw the river. Whoops. Draw a river, and on three sides by a fence. 1, 2, 3. And it's a rectangle, so I know that if this is the width and this is the length, this is also width and this is length. Okay, so I want 800 meters of fencing. What is the largest area you can enclose? So I want to maximize the area. So that means I need a function for area. Okay, so I know area is going to be length times width, but I also know that I have 800 meters of fencing, so 2W plus L should equal 800. So I can solve that for L, and I get L is equal to 800 minus 2W. So that's because 2 of these widths plus 1 of these lengths is the total amount of fencing that I have. And that other length is covered by a river, so I don't have to fence that part. So area is going to be 800 minus 2W times W. So that's 800W minus 2W squared. And how do I find the maximum? Well, I'm going to take the derivative. So A prime is going to be 800 minus 4W, and I can set that equal to 0 to find the critical points. So I can add the 4W over, divide by 4. And I want to justify that that's a maximum, so I'll just use the second derivative test. Sorry. A double prime of W is -4. So that's concave down, so it's a max. My critical point is a max. And so the width is 200, which means the length is 800 minus 2 times 200, which is 400. And the units are meters. The next one says a man 6 feet tall walks at a constant rate of 5 feet per second toward a street light that is 16 feet above the ground. So there's the 16 feet. There's the man 6 feet tall. And then it says determine the constant rate at which the length of his shadow is changing as he walks toward the light. So he's 6 feet tall, and he walks at a constant rate of 5 feet per second toward the street light. So if this is x, then that means that dx dt is going to be what? Well, is x increasing or decreasing? Well, if the man is walking towards the street light, then x should be decreasing. So dx dt is -5 feet per second. And this is 16 feet high. And then I want to know the constant rate at which the shadow is changing. So the shadow is this length here. And so I'll call that y. Okay, and so how can I have a relationship between x and y? Because I want to find dy dt. So if I have dx dt and I want to find dy dt, I'm going to start by making a relationship between x and y, and then I'm going to take the derivative of that with respect to t. So what's the way I can relate x and y? Well, I can notice that I have some similar triangles going on. That 16 divided by 6 should be equal to x plus y divided by y. Or in other words, 16y should be equal to 6x plus 6y. And so I can take the derivative implicitly with respect to t from both sides, and so I get 16 dy dt equals 6 dx dt plus 6 dy dt. And now I can plug in my value of dx dt that I know. I know dx dt is -5, so I'll plug that in here. I'm going to move over here real quick. And I can also subtract that 6 dy dt over. So I get 10 dy dt is equal to 6 times -5, which is -30. And I can divide that by 10, so I get dy dt is equal to -30 over 10, which is -3. And the units for that are feet per second. Does it make sense that the shadow will be, the length of the shadow will be changing at a negative rate? Well, if you walk towards the lamppost, your shadow will be getting smaller. So that does make sense. All right, that's it.